Might take about 30 more seconds. Looks like most of y'all are done. Or taking a zip with it. I can't tell which. Alright, couple of announcements while you're finishing up. Friday's a big day for you. You have a quiz Friday, which will include mostly balancing chemical equations and law of conservation of mass, which we're going to be going over this week. Y'all have already done some of it already, whether you realize it or not. Also, your projects are due this Friday. That's your element superhero or supervillain project that I gave you several weeks ago. That is due Friday. That is a test grade. Picture days Friday. So if you need a picture day form, I have a few extra. Your progress reports, you need to turn them in by Friday, either to me or to Ms. Akko or whoever. Turn them in to somebody. Progress report? You get progress report Friday? Or I got plenty of time to make phone calls Friday afternoon. I'll be on the road. So I can call anybody that hasn't turned one in, I can call, make sure the parents are informed about your grade.
Yo.
We do have progress reports Friday. Why are we getting them in?
No, they're due Friday. Like you need to have them sign and turn it back in. Our classes are also participating in the 100 Acts of Kindness Challenge. This is a very easy challenge for you. What it is that each class is challenged to do 100 acts of kindness, not in class, but that'd be cool. But throughout your day, either at home or here, if you do something kind, you write what it was that you did up on the board. You don't have to put your name. And then the contest ends at Christmas. So when we leave for Christmas break, our goal is to have 100 acts of kindness. So if you've done something kind, when you come in my classroom, find second period, don't write me a book, just put a couple words about what you did.
So if we get somebody a picture of that card?
walk up to somebody like, take my pencil. That's weird. But if somebody needs a pencil and you give one, that's kind. All right, my goal is to get 2 labs done today, so we need to work quickly and you need to pay attention so that we can keep rolling. All right, number 1, which one of those is a compound? Sayer, this goes to you. It is A. We know that because a compound is 2 or more different elements bonded together. All the rest of these may be more than one element, but they're the same. So O2 is 2 oxygens into 2 nitrogens. The only one that has 2 elements that are different bonded together is A. Number 2, look at the following equation for photosynthesis. What does photosynthesis produce? And this goes to Jacob. Which one? B, very good. A compound and a molecule. The compound is C6H12O6, and what is that compound?
Salt.
Not salt.
Isn't it like carbon dioxide and water?
Nope. It's one of your flashcards. Glucose, very good. O2, which is oxygen, is our molecule. Remember, compounds are different elements. Molecules can be different or the same. Number 3, how was the periodic table arranged before there was knowledge of subatomic particles? This goes to Nelson. Which one? C, by similar reactivity. That is correct. They didn't, this is a popular answer right here, by atomic weight. People love to put that. But remember, this is before they knew about protons, electrons, and neutrons. So they didn't know about atomic weight. Dude, Dmitry Mendeleev, whenever he was organizing the periodic table, he grouped them by similar properties, which means reactivity is one of those properties. Oh, throw that one away. Number 4, rust is scraped off the side of the car. Is the removal of rust a chemical change or physical change? This goes to Madeline. It is not chemical, it is physical. Here's why you get confused. Y'all see rust, and you're like, this time it says rust is a chemical change. I know that one. That's true. Creating rust is a chemical change. The formation of rust is a chemical change. However, this question is asking you about scraping rust off the side of the car. That's the same thing as tearing up a piece of paper. It's still rust. You're just scraping it off the side of the car, so it's a physical change. All right, put that away. You're going to be adding to it in the week, and then you're going to be turned in, so don't lose it. All right, let's see. Janaya, Alex, Maria, Jose. Y'all need to come take your quiz. Bring a pencil. All right, today we're going to be working on more chemical reactions and chemical properties. For our first lab, this is what I wanted to do last week, but I didn't have all the chemicals in. We did this in Science Olympiad. I just enough to do it for them, but now I can do it for everybody. So this requires you to listen to each step very carefully or it will not work. So what I want you to do, one person from a group, when I say so, you're going to go back and get one of the baskets on the back counter. There should be 6 of them. 5 of them look similar, and there's one kind of. This is your one. one morning. Another person from each group come up and get enough goggles for your groups. Go ahead and go.
What you mean? It's going all the way down at the end.
In front of the
What's this?
That is a vent, so that if your goggles start fogging up,
You open it and
and
you
let
like
air
it.
in. All right, first thing I want you to do is carefully take the green cup out. No, the first thing I want you to do is put your goggles on over your eyes. Make sure you don't have any food, drink, or gum, or you get kicked out of the lab. So take care of your business right now. All right, after you put your goggles on, you're going to take the green cup out of the basket. There is a solution in there already. Please do not spill it. Just set it to the side. We'll use it in a minute. This activity calls for 3 major steps. It's a creation of a vitamin C stock solution, and then we make 2 more solutions. The good news is that since first period made up your vitamin C stock, you don't have to do it. They had leftovers. So the way they made the vitamin C stock is they took a 1,000 milligram tablet of vitamin C, they crushed it up into a powder, and they added 60 milliliters of water and then stirred it until it mostly dissolved. So that was how they made their stock solution. What we're going to start with is the second step, which is to make solution A. Now solution A is 60 milliliters of water, 5 mLs of the vitamin C stock, that's the stuff in the green cup, and then 5 mLs of tincture of iodine. In your, I'm not gonna use that. In your basket, you should have 2 droppers. You need to keep these separate, so when you use one on the vitamin C stock, put it to the side, you're done with it. Each dropper is enough for 1 milliliter when you fill it up to right before the bulb. If you look closely, right before the bulb, there's a marker, and it says 1 ml. So whenever I say 5 mLs of something, you're going to put your dropper into the solution, squeeze to let the air out, and then slowly release so that the liquid is drawn back up until it gets the 1 ml mark. And then you're going to transfer the solution. And then if you have 5 mLs, you're going to do that 5 times. If you have 15 mLs, you're going to do it 15 times. Everybody see how that works? I'm not going to have you do 5 mLs in a graduated cylinder. You're not going to be able to get accurate readings like that. The graduated cylinders, they're a very big group of air when you're only messing with like 5 mLs of something. 5 mLs is 1/6 of a tablespoon. So it's not a lot. It looks like a lot, but it's really not. So the first thing I want you to do is just pick a beaker, doesn't matter which one. You're going to have one person go get 60 milliliters of water, and then you're going to add 5 milliliters of that vitamin C solution. Be sure to stir it up before you use it. When you are done, when you're done, raise your hand, and then I will come around and add your iodine. I don't want to pass that around because it will stain the crap out of your clothes, like forever. So I will walk around and add the iodine to your solution. So one person up at a time, go ahead. There's 3 water buckets in back, 2 up front. Plenty of buckets for everybody.
Where's 60? Where's 60?
Yeah, you're going to use a graduated cylinder that's at the bucket to help you.
They told me to bring that. Do I bring this?
I would. Doesn't really matter, but I would.
Wait, you said 60, right?
60.
It was from the bottom. Hey, no, no. She said I. No.
Mhm.
It looks like it's just one big drinking glass.
It really is because I'm out of beer. So good, good observation. All right, 60 ml of water, come on.
Wait, can we put the water in there or that in here?
You put the vitamin C solution into the water.
We can do it?
Yep, 5 ml. So 5 cupfuls.
What are you bringing?
Why is there 2 of you up at a time? Why do you have a red cup?
I thought that was what we were supposed to have.
Mm-mm.
Can we stir it up?
Swirl it.
Put that in it.
Oh, wait, you're.
Once you've added the 5 milliliters of vitamin C solution, raise your hand so I can write the iodine in it. That's what I thought. When I put the iodine into your vitamin C solution, you will already notice one chemical reaction happening. The vitamin C breaks the bonds of iodine and creates a new solution. I will not tell you the whole chemistry behind it because it's like line after line after line of gibberish for those of us that are not chemistry professors, but you will see what happens.
It keeps going away.
So she could put it in.
So what evidence of a chemical reaction is that?
Oh,
It went away.
It went away, so what happened
oh my god.
to?
He drank it.
So.
He's a magician.
Stop raising it.
Don't use your hoodie to clean it.
I wasn't.
So when the iodine goes into the solution, you say it goes away. It doesn't go away. It's still there, but it's a new solution, it's a new chemical property. So there's a change in color. Going clear is a change in color. said it wouldn't jump.
Shots up, my boy.
All right, that is our solution A. Once you have your solution A, just put it to the side. We'll get back to it in a minute.
He messed up. He messed up, yeah.
You got another dropper pool? All right, now swirl it up.
He really
All right, there you go. This means you didn't add enough. All right, next we're going to be creating our solution C. I'm sorry, solution B. Third solution. Solution B is another 60 mLs of water. And then you're going to add 15 mLs. Pay attention.
What is you doing? Boy, sit down.
You're going to add 15 mLs of hydrogen peroxide and 2.5 mLs of laundry starch. The hydrogen peroxide and laundry starch are in your baskets. 2.5 milliliters is 2.5 dropper pools. You got that? So 60 mLs of water, add 15 dropper pools of peroxide, 2.5 dropper pools of laundry starch. Okay, now you go. Alright, add your 5 dropper pools. So you're going ahead and get 60 mLs of water.
Where do we put this? In the green cup?
No, in the cup of
He's gonna put 60 mLs of water in here.
Okay, that's cool. You messed it up down there. No, no, no.
There you go, that's it. Push.
Miss Thomas, it doesn't even look like this for it to be dropper pools.
It doesn't look like it does.
One.
It'll be close.
Yes.
Each one of these cups is like 2 ounces.
Wait, that's. No.
You might need to add another dropper or two.
Wait, what?
Check the board.
You guys already did 14. You said one more.
You have to do 15.
Hydrogen peroxide is 15. Laundry starch 2.5. Shayla, put your goggles on.
It took up the whole thing.
If you need more, let me know.
No, we already got this.
Just know.
I lost count. I think I read. Let's see.
That's more than that.
So you add it to your water. That 60 mLs of water you just got, that Sayer just got, 15 mLs, yes. All of it, 15 mLs. Don't you dare pour that in, you better measure it.
Don't. hydrogen peroxide.
Y'all shouldn't be smelling anything, I did not give you permission to smell it. You should only see one, you need the 15 of those drummer holes in there.
It's salt water.
Yep, that's one, so fill it up to there. 15. So you, seriously. See his partner. All right, who has that last solution made up? Raise your hand. All right, let's give it another minute. I want everybody to be doing this at the same time.
It's all cloudy.
This is laundry starch. All right. We're just waiting on one. All right, so this reaction is a two-part reaction. One we already saw with the iodine changing colors. So we formed a new substance that had new properties. The properties of that substance was that it was clear. So now we have a clear and an almost clear solution. We're going to mix those together, and then we're going to observe the second chemical reaction. This is called the iodine clock reaction. The reason why it's called iodine clock reaction is because it takes a minute. Sometimes it happens almost right away. A lot of times it takes like 1 or 2 minutes for a reaction to happen. So if you did it correctly, after a little bit, you'll see the reaction. If you don't see a reaction, it means you probably didn't do it right. Last class period, one of them took almost 4 minutes to have a reaction. We thought we're like, you did something wrong. Next thing you know, oh wait, no, there you go, you're good. So you're gonna find out what's gonna happen. Nothing's gonna explode. Don't explode in the middle school. So it doesn't matter which one.
What's supposed to happen?
You will find out. So what I want you to do is mix one with the other. It doesn't matter which one, and then you're going to gently swirl it. So pick it up and swirl it until you see a reaction.
Which one we put it with?
Doesn't matter. Doesn't matter as long as they get mixed. And then you
Oh,
gently
it turned
swirl
red.
it. You did something wrong. Yo!
Oh my god.
We are hackers.
This
There it goes.
This.
Well, it's not related to.
Whoa, I thought we did it wrong.
It's Kool-Aid.
Kool-Aid.
It's my marker.
keep on checking it. Keep on swirling it.
Oh, this
We didn't do it right.
Keep on swirling it.
Don't give up.
No.
Nobody uses droppers here, y'all swirling methods are subpar.
Oh, I guess I'm.
Bro, come on.
All right, so our secondary chemical reaction, what evidence do we have of a chemical change?
You did it wrong.
What evidence do we have of a chemical change?
It turned on.
It turned purple, which is a color change, which is one of our indications that there was a color change. I'm not talking about adding purple Kool-Aid powder. I'm talking about taking two clear liquids, combining them together, and making a color. That is classic chemical reaction. So what I want you to do, I'm gonna call you a group at a time. You're going to, these are all safe to put down the drain. So carefully, because I will tell you, this purple solution will stain the crap out of your clothes too. So you need to carefully pour it down the drain with some water. Thank you. Once you've done that, please rinse out all beakers, all cups, all of the droppers. The droppers need to be rinsed out as well because we will reuse those. So James group, since yours changed first, why don't we start with your group? And then you can leave the basket and all the supplies back on the back counter once you're done cleaning them up. And then we will move on to our second lab of the day. Each group needs to get a piece of paper. You can put your goggles up on your head for right now. We'll put them back on in a minute. Each group needs to get out a piece of paper. You can be a scrap piece of paper or,
You have some in the back?
I do, but your group might have some. I'm hoping one of the four of y'all has paper somewhere.
I just don't want to get it out, ripping it out my notebook.
Oh, it's stinging.
Which one is it?
Now I'm on.
Don't throw them out, you rinse them out.
Now I'm on Kool-Aid.
I know, right? Great crush would be good.
And just make my tongue purple.
most
They
likely.
die, yeah.
It looks black. Ours is black.
Alright, more
It's
quickly.
purple. What color is it? Blue. That's black, right?
Alright, every group should have a piece of paper out. I told you to do that several minutes ago. I need a scrap piece of paper.
Hold on. I wanna try.
Really?
Don't put them in.
Yeah.
Alright, Andrew, go to clean out your stuff.
Come on. You said Andrew's.
It went in there.
we do something like it.
Like-
Like a demonstrate.
Big soda.
And then there's one reaction I save until the end of the year.
Yeah, baking soda.
Now, I do a better one than that at the end of the year.
Can you have a
That reminds me.
Well,
Can we have a project where we could bake a volcano? Yeah.
No,
Science
that's
fair.
elementary school.
I never made a volcano.
Alright, Alex's group, go play up.
but then you're looking for blue ball.
Droppers, beakers, whatever.
There's no more music.
I never said that. I
There's
swear
a
to
blue
God.
in there. Drop it down, thanks. You are. I say blue. It's my favorite drink. Oh. No, I think you're having this leader. Yes, I'll go ahead and.
Bring out the little color.
We don't got it.
Cause it is English. And you're the mic.
Supposed to keep that back there.
No, the flag.
Kaden!
Supposed to keep that back there.
Let's keep it back there.
Alright, Janice's group, please go clean out these slides.
What's that?
We don't miss out too?
Yep. It's flat. I do. No. It's pretty flat too.
We'll trade drinks, bleach for Coke.
What are you doing?
Busy?
Are we gonna use
Blow something up. Ooh, I'm gonna get it.
Big Cholo.
Alright, when you miss the bus, you miss it. Alright, Douglas group. What we're gonna be doing next is exploring a chemical property, which is pH. Remember from our notes, pH is how acidic or how basic something is, or how alkaline it is. Now with pH, there is a color scale that we use along with a paper called litmus paper, and that's those yellow papers I handed out to you. Those little yellow papers, they have chemical bonds on them. Jane, pay attention. That react with liquids in order to determine whether they have a low pH or a high pH. Remember, the pH scale goes from 0 to what?
7.
14.
Thank you,
0 to
14,
100.
sheesh. 0 to 14. What is the pH of water?
Neutral.
Which is what number?
2,
2.
3, 4,
5.
3.5.
What is half of 14?
3.7.
7. The pH of water is 7 because it is neutral. It's right in the middle. So if you have a scale from 0 to 14, right in the middle, 7. All right, Jason's group. If you are an acid, your pH is what?
Below,
What range? Below what?
below 7.
Below 7.
What's an acid?
An acid is anything that has a pH less than 7. So it's a pH of 1 through 6. If you are a base or an alkaline, you have a pH greater than 7. So it's everything 8 and above. The higher, the higher or lower the number is, the more concentrated it is. So a really concentrated acid will have a very low pH of like 1 or 2. And a very concentrated base will have a pH of 10, 11. Those are usually more dangerous than things that are closer to neutral, closer to water.
I live beside shop. I live beside I am a registered.
I showed you some pH probes last week to where we'll be using them. We're doing labs. You can't have computers around labs. To where we'll be using digital equipment to take the pH of something. However, for today we'll be using a more traditional method, which is this litmus paper. Litmus paper comes with a chart, and this chart's a little hard to see on the document camera, but we'll make the best of it because I only have 4 of these, and there's 6 groups of y'all. So on this litmus paper, what color it turns when exposed to the liquid is what pH it is. Is this a very accurate way of measuring something? That's something you guys need to think about as you do your lab today. What you're going to do is test the pH of the 3 substances I gave you. Before you open any containers, your goggles must be on. Thank you. The way you use this litmus paper, all you have to do is hold it, dip it in the liquid. That's all you have to do. You do not leave it in the liquid. You dip in the liquid, pull it out, and you set it on your paper, and you check the color change. You're going to be comparing it to this pH chart up here. The 13s, 12, 13, and 14 range up here, these are all kind of like a dark purple or maroon color. The rest of them you can almost see clearly. 10 and 11 are like a dark green, and then it goes from light green to yellow to orange to red. So the further down the pH scale, and I did not tell you to start yet, but okay. This is why I don't want to mess with you. Why are you still continuing to work when I haven't told you? The further down the scale you get, the brighter the color is going to be. Now this does not mean that this is the same scale for all pH indicators. Some pH indicators have different color spectrums, so a purple may be a 7 on one, where it's a 14 on ours. make sure that once you have dipped in your pH solution and set it on your paper, you go ahead and put the lid on your solution so nobody accidentally knocks it over and bleaches their nice sweater. So go ahead and start with one of your solutions. Do one at a time so your group can compare it.
What color is this?
Ask your group,
What color is this?
put it on the paper so you can see it more clearly.
That is right.
Some of the reactions take a second for it to occur. Most of them occur fairly quickly.
That's green. That's red. That's orange.
It's on schedule, but you gotta change this computer. It's not, it's
Oh,
not.
that is another dip. Doesn't matter.
Don't. First, I need to get that because your desk is wet.
It's not,
Yeah, my paper don't work.
it's yellow.
I mean, it don't work.
The bleach isn't working.
It's, you see through the paper now. Get the paper down. No, no, no.
That's a 7.
It's supposed to be clear.
Put the top on your bleach. Quit. You're not supposed to do that without permission.
Is yellow supposed to be, like, is the paper supposed to be yellow? Like, whenever you dip it?
It's not yellow. That's not.
Oh,
Has everybody had a chance to dip their pH strips? All right, what did you notice about the water?
The water turns green.
It's an 8.
Somebody give me the results of their water strip, and it sounds like some of y'all mixed
it
it
turned
up.
green. Ours turned, 7.
Okay, who else?
That's not a.
Ours turned
Oh, 'cause water's neutral.
Ours turned 8.
Right, read it. Water's neutral. 7.
So if you did not have any cross-contamination, which is why we only do one at a time, it should have been within the 7.6, maybe close to the 8 range, because it is tap water. It's not pure water. So it should be right in the colors in the middle of the pH spectrum.
You got it from back there? It's the water fountain tap water too?
Everything you drink in this whole building is tap water. I hate to tell y'all, everything's tap water. I don't know why y'all freaking out. Y'all been drinking tap water all your life. There's like pretty much no difference between tap water and bottled water.
Is water
If it's distilled water, there's a difference. Bottled mineral water, it's tap water. That's all it is. All right, the bleach. What did you get for the bleach?
It's like,
Maybe
Six.
I could almost say that.
3. And then it went to 6. It made
Yeah, I
it
got a red.
Yeah, then you got something mixed up. The bleach, bef-
I got vinegar.
if you let it sit long enough, it's going to turn a very light yellow, and that's because the paper is being bleached. The first thing you should have saw was something around the 9-10 range, 8-9-10 range, something like a greenish color. And that is also a reason why you may have seen a little bit of that color in your water, because there is a tiny amount of bleach added to tap water in order to kill organisms.
Oh.
Those things you didn't want to know about your tap water.
Wait, we drink bleach?
That's why if you ever like get tap water, it smells like chlorine. They add chlorine into the water. That's what you're supposed to add to water. Okay, survival moment. If you are without running water and you got to go get water from a creek, river, stream, whatever, the way you make sure that it's safe to drink is that you can add in 1 drop of bleach.
Who carries bleach with them?
And that kills any microorganisms that you can't see in there, so it makes it safe to drink. They make like bleach tablets sometimes you can carry in a bottle, so if you're out hiking or whatever and you can add it in there. Iodine does the same thing. So they make iodine tablets. Both of them taste, nasty, but it's safe to drink. Fun fact. Okay, what about your vinegar?
3 or 4.
Red.
You said red, 3 or 4.
Which is 2.
It was red at first and then red and orange.
3.
Vinegar is very acidic, especially white vinegar. White vinegar is pretty
It's
acidic.
3 or 2.
So you should have seen it in like the orangey reddish spectrum.
And it transfer onto the white paper.
Why does it
Yeah. So these are things you need to know when they talk about on tests for litmus paper. When they talk about color changes in regards to pH. pH is a chemical property. Even though we just, dip the little thing in and it changed color, that changing of the color on the paper is a chemical change. That's how we can detect pH. We have to do a chemical change in order to detect pH. So it is a chemical property. All right. Make sure your lids on your paper, one person from each group needs to throw away your paper and litmus strips. I'm going to give a Clorox wipe to each group. You guys can clean your goggles and one person take them up, put them in the basket. I'll come around and collect little
You
puppies.
know, my table.
You go.
Make sure your tables are wiped down. If they got wet, wipe them down.
She said we washed our goggles.
Yes.
He was like,
Wipe the goggles, put them in the basket.
bro, why y'all put it on my day? I'm not skilled.
Are you washed?
Let me see, you give me. No. But I'll give me orange.
You said Martha orange.
You drink out of that?
I don't plan on drinking out of that.
No, like, big. Who gave you that?
Wash your goggles.
Why don't you wipe
Who
your
gave
goggles,
you
go
that
first
nickname?
from the group, go from the other
Who
half.
gave you that nickname?
Elementary school.
Damn, this smells it.
Hey, chill.
Oh, he put it away.
Your table wiped up, your goggles are wiped up.
What would happen if I put this in?
What? No. You're not supposed to.
You said give me it. Yes.
The people trick each other going downstairs last year, so. All right. Get rid of. I'll get written up. Yeah, 'cause you've already been told twice. All right, I'm gonna show you real quick demonstration. I don't know how well you'll be able to see this, but we're gonna go with it. In this beaker, in this graduated cylinder, I should say, is plain tap water. I have a piece of an acid tablet like Alka-Seltzer, except it's, off-brand because it's not cheap like that. When I drop, Alka-Seltzer in, you're not gonna be able to see that, I bet.
This quality is pretty good.
There we go.
There we go.
A little better. You can see it kind of.
Bubble.
It's bubbling.
You see the bubblies a little bit? To the point that it's kind of,
There you go, nice.
you just set it up on my desk anywhere. Thank you. All right. So we had a reaction. When you have a production of gas, that is a chemical reaction. And that's when we have just a liquid and just a solid making gas.
Alex. Whiplash. What are you doing?
In a minute, I'm going to show you something similar, and I want you to look carefully. Hey, it's Thomas. Hey, it's Miss Thomas.
Hey, Ms. Thomas, I didn't call.
No, but
I was calling for Ms. Freeman.
I know I'm calling you. Can you ask Miss Watkins to stop by, please?
Ask who?
Miss Watkins.
Sure, I will.
Okay. All right. Next thing I'm going to show you. Y'all may have seen this on a larger scale before. This is not Coke because I don't have any Coke. This is Dr. Pepper. You see the bubbles in it? Yeah, there's no light on the camera. It's an El Chico camera.
El Chico. El Chapo.
Nope, I don't have.
Bro. Turn the light up on the camera.
Aw, yeah.
There you go.
There we go. All right, I'm gonna add a Mentos. Do y'all see the fizz forming?
Yes. It's
Usually,
bubble.
all you push is wax.
So I'm gonna trip you up a little bit here. This is not a chemical reaction. This is a physical reaction. Does anybody know why it's not a chemical reaction?
Because it's still Dr. Pepper.
It's still Dr. Pepper, but you see bubbles. Did they know why it's not a chemical reaction even though we see bubbles? No. Hmm? What about the Dr. Pepper?
Does it have that same reaction like Coke does? No.
It is, but remember, when you have soda, it's already bubbly. I did not create any gases. All I did was release the carbon dioxide gas quicker by adding the Mentos. Mentos does not cause a chemical reaction. It is a physical reaction. It has tiny little holes in the candy that the carbon dioxide likes to stick to. And then once the carbon dioxide starts moving, it rises because it's less dense than the soda that it's in. So even though you see bubbles, we started with a gas. That's what the bubbles are.
Soda's the liquid.
What is the liquid?
Soda's the liquid.
Yeah, soda's the liquid. It's the carbon dioxide that's the gas in the soda. That's what makes carbon dioxide or makes soda a bit fuzzy. All right. Make sure everything's cleaned up and get out of here.